Hello folks, welcome to today's video. In this video we're going to talk about the first of what we refer to as the exponent laws. And so there are some laws, some generalizations that we can make when we are trying to perform multiplications and divisions with exponents. We're going to talk about those today. So the first thing we're going to do is take a look at these products down here and try to evaluate them. So the way that I'm going to evaluate them is going to just kind of match these brackets to the powers they're talking about. So 2 times 2 times 2 is 2 to the power 3, and 2 times 2 is 2 to the power 2. And 2 to the power 3 is 8, and 2 to the power 2 is 4, and 8 times 4 is 32. Now let's do the next one. So again, this is 2 times 2, which is 2 to the power 2, and then another 2 times 2, which is 2 to the power 2, and then 2 by itself, again, remember from the first video, we know is 2 to the power 1. So 2 to the power 2 is 4, and 2 to the power 2 is another 4, and 2 to the 1 is 2. So 4 times 4 is 16, times 2 is, again, 32. And then finally, 2 times 2 times 2 times 2 times 2. So we have 5 2's here, so we can think about that as 2 to the power 5, which again gives us 32. So notice the result in all three of these equations is 32, 32, and 32. So we can probably figure out that these are actually the same equation. We have 1, 2, 3, 4, 5 2's in each of these equations, which always gives us 32. But notice that sometimes those 2's can be split up into groups in different ways. So for example, the first one we had 3 2's and 2 2's, and the second one we had 2 and 2 and 1, and in the third one there were all 5 of them. So if we were to work my way backwards now, how could I do something like 2 to the 3 times 2 to the 2 and use this information to kind of work my way backwards? Well, that's our first rule. If I want to multiply two powers together, notice here I have negative 7 to the power 3 and negative 7 to the power 5. If I wanted to simplify this and write it as one power, I could, because they are both repeated multiplications of negative 7. So negative 7 to the power 3 is negative 7 times negative 7 times negative 7. And then they are being multiplied, so we can throw that multiplication symbol in the middle there. And then negative 7 to the power 5 is negative 7 times negative 7 times negative 7 times negative 7, and then finally times negative 7. Now notice here that the brackets aren't really doing anything. I know order of operations says we're supposed to do our brackets first and then whatever's left, but in this case, because the first 3 7's are being multiplied and the next 5 7's are being multiplied, and the middle operation is also a multiplication, it actually doesn't matter what order we do these multiplications in, we'll get the same result because we're supposed to multiply from left to right. So with that in mind, these brackets aren't actually doing anything, so let's just get rid of them. So this is negative 7 times 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 negative 7. And if we think about this as one big string of multiplications, notice we have 1, 2, 3, 4, 5, 6, 7, 8, 7. So these can be brought together as negative 7. And again, I want to make sure that the negative is the base because it is getting repeated, but so that's to the power 8. And in general, this is true. If I have two powers with the same base, so in this case, because both of them had the base negative 7 and negative 7, if we multiply those two powers, we can simply just add the exponents because this is telling me how many I have. So if I have 3 negative 7's, and then I have another 5 negative 7's, and they're being multiplied because that's what the exponent tells us to do. It tells us to multiply by itself 3 times. So if I have 3 of them and I have 5 of them, altogether I have 8 negative 7's. So I can write that as a power with base negative 7 to the exponent 8. Right, so when we will have the multiplication of powers with equal bases, then all we ever have to do if we want to write that as one single power is simply just to add the exponents. So for example, 5 to the power 5 times 5 to the power 4 can be rewritten as 5 to the power 5 plus 4, which is 5 to the power 9. Negative 3 to the 3 times negative 3 to the 3 can be rewritten as negative 3 to the 3 plus 3, which is negative 3 to the 6. Notice again, I'm including my brackets whenever I have those negatives to make sure that they get repeated. Negative 4 to the 1, which again, remember, is simply just negative 4. So if we ever had a question where we didn't have this negative 4 or this 1, we still have to understand it as negative 4 to the 1 times negative 4 to the 3 becomes negative 4 to the 1 plus 3, which is negative 4 to the 4. Again, this is 1, but if I wanted to think about that 1 as a power of base 2, then this becomes 2 to the 0 plus 4, which is 2 to the 4. And then down here, 12 to the 5 plus 12 to the 4, you might think is 12 to the 9, but I tricked you because it's not, because this is an addition. My rule only works if we're talking about product or multiplication. So this is wrong. And in fact, with this question, there's nothing else we could do with it other than simply solving, finding 12 to the 5 and adding it to 12 to the 4. All right. What about division, though? So something we have to understand is that division and multiplication have a certain relationship, usually because division can be thought of as multiplication. So for example, if I wanted to do like 8 divided by 2, well, I can think about that as 8 times 1 over 2, right? So because division and multiplication are essentially the same operation, that's why they fall in that group in our order of operations, the rules should apply the same. So let's see how. So if I wanted to do 8 to the power 7 divided by 8 to the power 4, first thing I'd like to do is I'd like to write that out as a fraction, just so I can kind of see what's in top and what's in bottom. So if I now expand this, 8 to the power 7 is 8 times 8 times 8 times 8 times 8, 1, 2, 3, 4, 5, 6, 7 of them, divided by 8 to the power 4. So 8 times 8 times 8 times 8. Now, because this is a string of multiplications, one of the nice things that happens here is we do something we call canceling. Now, canceling is a bit of this like broad term that means a bunch of different things, but essentially what's happening is whenever I take an 8 and I divide it by itself, anything divided by itself always gives me 1. And in math, when I am left with a 1, I don't usually write that. So because I don't usually write that, that's where we get this idea of canceling. It kind of goes away. So if I look at what's happening here, I have an 8 divided by an 8, so those are going to turn into a 1. And then I have another 8 divided by 8, so those are going to turn into a 1. And then I have a third 8 being divided by 8, so those are going to turn into 1. And then finally I have a fourth 8 divided by 8, so those will turn into a 1 as well. So what I'm left with is simply just 8 times 8 times 8 times a bunch of 1s, but 1 times 1 times 1 times 1 is just 1, so we don't write them out. So what is this as a power? Well, it's simply just 8 to the power 3. And again, notice I started with 7 and 4. Well, what is 7 minus 4? 7 minus 4 is 3. So just like with multiplication, when we divide powers with the same base, we simply just subtract the exponents. So when we multiply powers with the same base, we add the exponents. When we divide powers with the same base, we subtract the exponents. So let's do that. So 4 to the power 5 divided by 4 to the power 3 becomes 4 to the power 5 minus 3, which is 4 squared, right? 4 to the power 10 divided by, 15 to the power 10 divided by 15 to the power 0 becomes 15 to the power 10 minus 0, which is 15 to the power 10. 2 to the 12 divided by 2 to the 10 is 2 to the 12 minus 10, which is 2 to the 2. I don't know why I put a 12 there, sorry. Get rid of that. And 6 to the 5 divided by 6 to the 1 becomes 6 to the 5 minus 1, which is 6 to the 4. All right, so why do we care? So just like with everything else, these rules help simplify our lives, especially with questions like these ones, where you might not know what 2 to the 12 is off the top of your head. I don't, right? You might not know what 2 to the 10 is off the top of your head, but you can do 12 minus 10 fairly simply and get 2. And most of us know that 2 to the power 2 is equal to 4. So by knowing these rules, it's going to allow us to do questions that maybe we weren't able to do without the help of a calculator or something else. All right, that is it for today's video, and I will see you all in the next